66 million years ago, an asteroid the size of a mountain slammed into the Gulf of Mexico and ended the dinosaurs. You know this one. But on a ranking of how close this world has ever come to losing complex life, that famous impact barely makes the board. It was the mildest of the big ones. Earth has flirted with total death at least 8 separate times, and the 2 closest calls of all happened before animals even existed. They might be the reason you're here to watch this, so let's set the rules, because they matter. We're not ranking these by how famous they are or how good the movie version looks. We're ranking them by one honest question. How close did each catastrophe come to ending complex life on this planet? How deep did the bottleneck go? You can measure that a few ways. What share of species and whole genera got erased? How many entire ecosystems went dark? How long life took to crawl back afterward? And the biggest question, the one hiding underneath all the others. Did this event just reshuffle who was on top, or did it threaten life itself? There's an honest catch, though. Ranking these is genuinely contested, and anyone who tells you the order is settled is selling something. Change the metric and the middle of the list rearranges itself. Scientists argue about this in print, so treat the middle of this countdown as a real debate, not gospel. There is exactly one spot on this entire list that nobody disputes, and we are saving it for last. We're going to climb. We start near the bottom of the scale, with the disasters that were brutal but survivable, and we work our way up toward the closest call complex life has ever lived through. Then, when we reach the top, the whole story cracks open, because the 2 deadliest near-deaths in the history of this planet don't even fit on the normal scale. They came before there were animals to kill, and they may be the reason animals exist at all. 3 things are going to catch you off guard on the way up. The single most famous extinction of them all barely registers. There's a real mass extinction so overlooked that science didn't even notice it until the 1990s. And the closest life itself ever came to blinking out happened in a world you would barely recognize as Earth. A frozen one. And before that, a poisoned one. Let's start at the bottom. The 6th closest call is the one you already know by heart. At the close of the Cretaceous, 66 million years back, a chunk of rock and metal maybe 10 kilometers across came screaming in over what is now the Yucatan Peninsula in Mexico. It struck shallow water and buried itself in the crust, leaving the Chicxulub crater, a scar more than 150 kilometers wide that we can still map buried under the Gulf today. The impact flung a curtain of molten debris around the entire planet. That debris rained back down as glowing hot glass, turning the sky into a broiler and setting forests alight across whole continents. Then came the cold, as dust and soot smothered the sun, and photosynthesis stalled at the very base of the food web. The non-bird dinosaurs, the giant marine reptiles, the flying pterosaurs, the coil-shelled ammonites, all of them gone. This is the extinction on every documentary poster. The T-Rex, the fireball, the asteroid. It's cinematic, it's sudden, and it reshaped life on land. So why is it sitting way down here at the bottom of the closeness scale? Because by the raw numbers, it was the shallowest of the classic Big Five mass extinctions. Roughly 76% of species vanished, and only about half all genera. Now, 3/4 of species dying sounds like the apocalypse, and for the creatures living through it, it absolutely was. But hold that figure in your head, because everything above this on the list did worse. Some of it did catastrophically worse. The asteroid was a clean, fast execution. It killed the dinosaurs. It opened the door for our mammal ancestors. It wrote the world you live in. What it did not do was come anywhere close to ending complex life. The oceans kept their basic architecture. Whole branches of the tree of life survived intact. Recovery, in geologic terms, was fast. Famous, it turns out, does not mean close. The dinosaur killer is the celebrity of mass extinctions, and celebrities are rarely the most dangerous thing in the room. And while we're busy killing myths, let's take out a big one right here. Plenty of people assume the extinction that ended the Triassic period was the one that wiped out the dinosaurs. It wasn't. It did almost the exact opposite. That older event comes next, and instead of destroying the dinosaurs, it handed them the whole planet. 201 million years ago, the supercontinent Pangaea was beginning to tear itself apart. Picture a single landmass stretching from pole to pole, and now picture an enormous crack ripping down the middle of it, roughly where the central Atlantic Ocean sits today. Up through that rift came one of the largest volcanic events the planet has ever produced, the Central Atlantic Magmatic Province. Lava flooded across regions that would later become the Americas, Africa, and Europe. The eruptions belched carbon dioxide into the air over thousands of years. The climate lurched, the oceans turned warm and acidic, and about 80% of species died. Something like 48% of genera went down with them. But this is where it gets fascinating rather than just grim. Before this extinction, the dinosaurs were not the main characters, they were extras. The land was ruled by the crocodile line, a sprawling group of armored, often enormous reptiles called pseudosuchians that had beaten the early dinosaurs to almost all of the good ecological jobs. If you had walked that world, you'd have put your money on the crocs. Then those eruptions gutted the crocodile dynasty. For reasons scientists still argue about, the dinosaurs and their close relatives came through the bottleneck in far better shape than their rivals did. The survivors inherited an emptied-out world, and over the next few million years they exploded in size and variety, and became the dinosaurs that would go on to rule the planet for well over 100 million years. So the extinction people blame for killing the dinosaurs is the very event that crowned them, the opening act of their reign rather than the final curtain. But think about where this still lands on the scale. 80% of species is worse than the asteroid. This was a genuine catastrophe, and yet, just like the impact, it reshuffled the deck rather than threatening to end the game. Life itself was never really in danger. It was a violent changing of the guard, not a threat to the guardhouse itself. To find an event that actually gnawed at the foundations, we have to go somewhere stranger, somewhere hardly anyone, even the folks who love this stuff, has ever heard of. Because the next rung on our climb is a major mass extinction that science somehow missed entirely until 1994. Roughly 260 million years ago, during the middle of the Permian, in a warm, shallow sea covering what is now southwest China, the ocean floor split open and started pouring out lava. The eruptions stacked up a vast staircase of dark basalt we call the Siberian Traps, and you can still hike across those ancient lava flows in Sichuan and Yunnan today. The gases that came up with them, carbon dioxide and worse, warmed the world and choked the oxygen out of the seas. Roughly half of all marine species died. Some estimates push the losses towards 60%. Out in the warm shallows, the coral reefs collapsed. The ammonoids, those coiled, chambered shellfish that look like the alien cruisers from a science fiction film, got hammered. On land, the dominant animals of the age were the dinocephalians, big, thick-skulled, slow-witted proto-mammals, some as heavy as a rhino, that lumbered across the Permian landscape as the top plant-eaters and predators. They vanished. Up in the forests of North China, a huge slice of the plant species disappeared alongside them. This was a real planet-scale extinction on land and at sea. Why have you probably never heard of it? Because it was hiding. For most of the 20th century, geologists lumped these losses in with the far more famous disaster that came right afterward. The Capitanian event, as it's now called, wasn't recognized as its own distinct extinction until 1994. In 2019, two scientists, Michael Rampino and Shuzhong Shen, went further and argued that it deserves to stand alongside the classic Big Five as a genuine sixth major mass extinction in its own right. That claim is still being debated, but the case is serious. And now for the gut punch that makes this one matter so much. That famous disaster it was hiding behind, the one that struck right after it, it hit only about 8 million years later. 8 million years. In deep time, that is practically back to back, which means the planet absorbed two separate basalt mass extinctions, one right after the other, in the blink of a geological eye. The Capitanian was the warm-up act. It softened the world, thinned out the survivors, weakened the reefs and the food webs, and before anything had truly recovered, the main event walked on stage. We will get to that main event, but we're not there yet because there's a slower, sneakier killer we have to get past first. Not a single knockout blow, but a crisis that ground on for millions of years and finished off some of the strangest animals ever to swim. armored fish built like tanks, and it dragged nearly every reef on the planet down with it. The late Devonian world, roughly 370 million years ago, was the age of fishes. The seas were ruled by placoderms, fish encased in thick bony armor, and the apex predator among them was Dunkleosteus, a monster that could grow bigger than a great white shark, with a head sheathed in bone and self-sharpening bony blades where you'd expect teeth. It didn't so much bite as guillotine. Those warm, clear seas were ringed by the largest reef systems the planet had ever grown, bigger than today's Great Barrier Reef, built not by the corals, but by sponge-like reef builders called stromatoporoids. Then, over millions of years, that whole world came apart at the seams. This is the entry that breaks the pattern, because it wasn't one catastrophe. It was death by attrition. This Devonian extinction was a drawn-out crisis, smeared across something like 13 million years, with two especially lethal pulses. The first, the Kelwasser event, gutted the reefs and the warm water life. The second, the Hangenberg event, landed at the very end of the Devonian and cleaned house among the vertebrates. When the dust finally settled, roughly 75% of species were gone. The placoderms are the ones that sting. These armored fish had ruled the oceans for tens of millions of years, and by the end of the Devonian, every last one of them was finished. Not reduced or diminished, but erased forever, right down to the final species. Dunkleosteus and all its armored cousins simply stopped existing, and nothing like them has swum the seas since. Worse still was what happened to the reefs. Something like 99% of the world's reef systems were destroyed, and here's the part that's almost impossible to wrap your head around. Those Devonian reef builders never came back. The stony corals that build today's reefs wouldn't even evolve until the Triassic, many millions of years later. For a long, long stretch of Earth history after this, the planet essentially had no proper reefs at all. The oceans went quiet. What did it? The honest answer is that we're not certain, and it may have been a slow tangle of causes. The seas kept running out of oxygen, laying down black, lifeless muds that became some of the oil we drill for today. But one of the leading suspects is almost poetic. This was the era when the first real forests spread across the continents, when plants evolved deep roots and wood and grew into proper trees for the very first time. Those roots ground up the rock and flushed a torrent of nutrients into the sea. And one idea holds that this triggered vast choking blooms of algae that sucked the oxygen right out of the water. In other words, the plants conquering the land may have helped suffocate the life in the ocean. The recovery was so brutal that backboned life stayed tiny for ages afterward. There's a stretch of the early Carboniferous so empty of good fossils that scientists literally named it Romer's Gap, a 15 million year hole in the record where almost nobody got big. It took something like 40 million years before vertebrates grew back to their old sizes. As savage as that was, it still didn't threaten to end complex life outright. For that level of danger, we have to go higher. And the next one is, by the fairest measure we have, the second worst thing that has ever happened to life on Earth. About 445 million years ago, in the closing chapter of the Ordovician, life was almost entirely marine. Nothing much lived on the land yet. The whole show was in the sea, and the sea was crowded. Trilobites scuttled across the floor. Colonies of tiny animals called graptolites drifted through the plankton like living fishing nets. Early corals and sponges built reefs, and strange armored jawless fish nosed through the warm shallow water that flooded the edges of every continent. This was the first of the big five mass extinctions, and by loss of genera, it usually ranks as the second worst in the entire history of animal life. Only one event has ever beaten it, and that's the one we're building toward. Start with the raw numbers. Somewhere between roughly half and 60% of all marine genera were wiped out. Nearly 85% of marine species died. And it happened fast. The whole disaster was compressed into the final stage of the Ordovician, the Henantian, a window of little more than 1 million years, for a global catastrophe that is shockingly quick. But the way it happened is the truly nasty part, because life here didn't get killed once. It got killed twice from opposite directions. The first blow was cold. The supercontinent Gondwana had drifted over the South Pole, and ice sheets bloomed across it in a deep, sudden ice age. All that water locked up in ice dropped sea levels by something like 100 meters worldwide, and this is the part that made it lethal. Nearly everything alive lived in the shallow seas fringing the continents. Drain those shallow seas and you don't just inconvenience life, you bulldoze its entire home. Habitats that had teemed for millions of years just dried out and disappeared. That was the first pulse. Then, just as brutally, the ice let go. The glaciers melted, the seas came flooding back, and the water that returned was warm and starved of oxygen. The creatures that had toughed out the frozen world, the hardy survivors of the cold, now got clobbered from the exact opposite direction. Warm, stagnant, suffocating oceans finished off much of what the freeze had spared. Life was whipsawed between two extremes, cold then hot, drained then drowned, with no time at all to catch its breath in between. The casualty list reads like a roll call of the entire early ocean. The graptolites were gutted. Whole dynasties of brachiopods, the little hinged shellfish that carpeted the Ordovician seafloor, were wiped out, along with vast numbers of trilobites, bryozoans, conodonts, and reef builders. By some counts, 2/3 of all brachiopod and bryozoan families vanished for good. And here's the detail that ought to chill you. This didn't unfold across a rich, resilient planet like the one you live on, with life crammed into every crack from the mountaintops to the deep sea. Back then, nearly everything alive was packed into those shallow, sunlit fringes of the continents. Squeeze that single habitat hard enough, twice, from opposite directions, and you come frighteningly close to emptying the whole living world in one stroke. Scientists still argue over what really drove the whole sequence, whether it was purely the Ice Age or whether volcanic gases and shifting ocean chemistry played a bigger part than we used to think. But the shape of it is clear. Two pulses, opposite causes, one of the deepest cuts life has ever taken. It's also the odd one out among the great extinctions, the only member of the Big Five to strike while the planet was locked in an ice age rather than sweltering in a greenhouse, which makes it our clearest natural experiment in what a deep freeze does to a crowded living world. And even so, complex life pulled through. Even after losing that 85% of its marine species, the oceans slowly rebuilt themselves. The tree of life kept its trunk, and that tells you something sobering about the event waiting at the top of this list, the one that makes even this look survivable by comparison. If you're enjoying this, hit subscribe. There's a lot more ahead. Now we've reached the summit of the scale, the single closest call complex animal life has ever survived. The one spot on this whole list that no scientist disputes. About 252 million years ago, as the Permian drew to its close, life on Earth very nearly ended. Not reshuffled, not merely knocked back, but dragged right to the brink of extinction. This is the Great Dying, and it holds a record that has never been broken, and that we can only hope never will be. Up to 96% of all marine species vanished. On the order of 80% of all genera, across land and sea together, were erased. Around 70% of land vertebrate species died. And in a detail that tells you just how total this was, it is the only mass extinction that ever managed to devastate the insects, the toughest, most adaptable animals on the planet. Bugs almost never go extinct in bulk. This time they did. Whole ecosystems didn't just lose members, they stopped functioning altogether. The reefs went, the forests went, and the intricate food webs that had taken hundreds of millions of years to assemble came apart at every joint. What remained was a kind of ruined, stripped-down husk of a planet. Recovery didn't take thousands of years or tens of thousands. It took something like 10 million years for life to rebuild anything resembling a rich, varied living world. That is the aftermath of an event that came within a whisker of resetting the animal kingdom to zero. So what on earth could do this? The trigger was the Siberian Traps, yet another flood basalt eruption, and the biggest one we know of anywhere in the record. Lava buried a chunk of Siberia the size of a continent. But the eruptions themselves, as vast as they were, aren't quite the whole story. The truly diabolical part, the thing that turned a terrible volcanic episode into the worst catastrophe in the history of animals, was where all that magma went. As the eruptions cranked on for ages, sheets of magma didn't only reach the surface. They punched sideways underground, straight into a buried basin packed with coal, oil, and salt, the fossilized leftovers of even older living worlds. Picture ramming a red-hot iron bar into a coal seam soaked in petroleum. The magma cooked those buried deposits and cracked them wide open, and out came an almost unimaginable volume of poison. More than 100,000 billion tons of carbon dioxide, by some estimates, along with a witch's brew of toxic ozone-destroying gases. And that gas didn't just seep out gently. In places it blasted to the surface through explosive vents that left craters more than a kilometer across, like the barrels of enormous planetary shotguns firing greenhouse gas into the sky. The consequences stacked up fast. The oceans warmed so violently that tropical surface waters may have climbed toward a lethal 40 degrees Celsius, opening a dead zone across the equator where almost nothing could survive. They acidified and suffocated. And high up in the atmosphere, the shield of ozone that normally blocks the sun's harshest ultraviolet light appears to have partly failed. We can see it written into the fossil record, which from this exact moment is littered with malformed, mutated plant spores, pollen deformed as though it had been sunburned at the genetic level. The land itself was getting irradiated. If you want a single survivor to remember out of all this, meet Lystrosaurus, a stocky, barrel-chested, roughly pig-sized plant-eater with a face like a cross between a lizard and a hippo. In the wrecked world, after the Great Dying, this one dogged little creature became so overwhelmingly common that for a while it made up a huge share of all the large land animals on the entire planet, an entire world's worth of ecological jobs, dominated by one stubborn survivor. That is what rock bottom looks like. No event in the whole story of complex life has ever come closer to ending it than this one, number one on our scale. And that, you would think, is the end of the list. But it isn't, because we've been asking the wrong question this entire time. Here's the trick we've been playing on you. Every event so far, we ranked by how close it came to ending complex life. Animals, plants, the rich living world you would recognize. By that measure, the Great Dying wins hands down. But complex life is young. For most of Earth's history, there were no animals at all, just microbes. And for an enormous stretch of time, the whole story of life was a story of single cells. So there's a second, deeper question buried under the first one. We haven't been asking how close the animals came to ending. We've been circling something far bigger. How close did life itself, in any form at all, come to ending? And when you ask it that way, two events blow everything we've talked about clean out of the water. Neither of them makes the normal list, because both happened before there were any animals to kill. Somewhere between about 717 and 635 million years ago, during a chapter of deep time we call the Cryogenian, the entire planet froze. And not an ice age like the ones the mammoths lived through, with ice caps at the poles and over to the equator. This was something almost beyond imagining. Glaciers grinding all the way down into the tropics, ice, possibly kilometers thick, creeping nearly to the equator. A white planet seen from space, like a frozen marble hanging in the dark. And it happened not once, but twice. The first freeze, the Sturtian, is the truly monstrous one. It locked the planet in ice for something like 56 million years. Not 56,000, but 56 million, a frozen world that lasted longer than the entire stretch of time that has passed since the dinosaurs died out. The second freeze, the Marinoan, came later and ran shorter, but it still entombed the planet in ice. How do we know the glaciers reached the equator? The rocks tell us. Ancient glaciers drag and dump distinctive debris, including stones plucked off the land and dropped onto the seafloor by melting ice. We find those glacial deposits preserved in stone, and using the faint magnetic record locked into the rock, we can work out that some of them sat at tropical latitudes at the time they formed. Glaciers at the equator. It's the unmistakable fingerprint of a world gone almost entirely white. Under all that ice, the living world was in agony. Sunlight couldn't reach the sea, oxygen levels in the ocean appear to have crashed, and much of the planet's algae and microbial life very likely died off in the cold and the dark. If you are hunting for the moment the whole biosphere came closest to simply freezing to death, this frozen stretch of the Cryogenian is a leading candidate. And now the twist that makes this the strangest entry on the entire list. What shows up right after the Great Thaw, almost the instant the ice finally melts? The first animals. Those soft, quilted, deeply alien early creatures we call the Ediacaran biota, the earliest complex life we know of, appear in the aftermath of the freeze. And the catastrophe that nearly killed the entire living world may have been what set complex life in motion. Squeeze life through a near-death bottleneck, then flood the thawing oceans with oxygen and nutrients, and something brand new crawls out the far side. You, eventually, included. Now, be honest about the debate here, because it is a real one. Some scientists argue for a hard snowball, a planet frozen essentially solid from pole to pole. Others favor a slush ball, with a thin belt of open water surviving near the equator where life could cling on. The difference matters enormously for just how close this came. So put an asterisk on it, but even the gentler version was a planetary catastrophe, unlike anything in the entire age of animals. There is only one event left, the oldest, the strangest, and by one honest reading, the closest life on this planet has ever come to ending. And the killer was oxygen, the very thing keeping you alive. Wind the clock back about 2.4 billion years, more than half the age of the Earth, to a world that would feel like an alien planet. There were no plants and no animals, no fish, no bugs, nothing at all you could have seen with your own eyes. The oceans were ruled by microbes, and crucially, almost all of them were anaerobic, meaning they lived without oxygen. To most of them, oxygen wasn't fuel. Oxygen was poison. Out in those seas, though, one group of microbes had quietly invented something that would remake the whole world: cyanobacteria. The blue-green mats that still build layered mounds called stromatolites today had learned to photosynthesize, and they pumped out oxygen as their waste product. For a very long time it didn't build up, because the oceans were loaded with dissolved iron that grabbed the oxygen the instant it appeared, rusting out of the water and drifting down to the seafloor in great banded layers. Those layers became the banded iron formations that we mine for most of the world's iron today. The steel in your car, in your kitchen, and the building you might be sitting in is, quite literally, the rusted-out wreckage of the first oxygen crisis. But the iron sinks eventually filled up, and once there was nothing left to soak up the oxygen, it started building up in the water and, before long, in the air. For the anaerobic microbes that had ruled the planet for over 1 billion years, this was a slow-motion apocalypse. Their entire world was filling up with a corrosive reactive gas that damaged their cells and killed them right where they sat. This was Earth's very first mass extinction, the Great Oxidation Event, and it has a much grimmer nickname: the Oxygen Catastrophe, sometimes the Oxygen Holocaust. And here's the bitter irony sitting at the center of it: the killers were the victims. Those oxygen makers were quietly poisoning themselves and everything around them with their own exhaust. And the microbes that survived didn't conquer the new oxygen world. They ran from it. They retreated into the last airless corners they could find, deep in the seafloor mud, inside hydrothermal vents, buried in sediment. And their descendants are still hiding in those places today, including somewhere a lot closer to home than you would like. Some of the anaerobic microbes living in your own gut are refugees from a poisoning that happened 2.5 billion years ago. But the extinction wasn't even the worst of it. That rising oxygen reacted with the methane in the early atmosphere and destroyed it. And methane, back then, was doing a critical job. The young sun was noticeably fainter than the one you know, and the methane greenhouse was one of the main things keeping the planet warm enough for liquid water. Strip the methane away, and the temperature fell off a cliff. Earth plunged into the Huronian glaciation, a freeze that ran from roughly 2.4 to 2.1 billion years ago, and which may be the single longest ice age in the planet's entire history. Life had poisoned itself, and later frozen itself in one connected catastrophe, on a world that had barely gotten started, nearly finished before it truly began. And yet, that same oxygen catastrophe is the only reason the air has oxygen in it at all. Every breath you take is a gift from the exact event that almost wiped the slate clean. The poison became the whole point. How close has Earth come to dying? By now you can probably feel the honest answer. That was never one question. It was two, folded up inside each other. If you're asking how close complex animal life ever came to ending, there is a clear champion, and it isn't the asteroid everyone pictures. It's the Great Dying, the end Permian, when the Siberian lava fields cooked a buried world of coal and salt and came a hair's breadth from wiping the animal kingdom off the board entirely. Number 1. No argument. But if you're asking the deeper question, whether life itself ever truly teetered on the edge of vanishing, then the answer lives far back in deep time. In a planet frozen down to its equator, and before that, in a world poisoning itself with its own first breath of oxygen. Those may well be the closest calls of all, though you have to say the next part plainly. We are much less certain about the deep past. The true magnitude of those ancient near-deaths is genuinely debated, and honest scientists disagree about how frozen the snowball really got and how much the oxygen crisis actually killed. And that same uncertainty runs right through the whole list. Only the very top and the very bottom hold still. Everything in between stays a live argument. The famous asteroid stays mild. The Great Dying stays supreme. There's one last uncomfortable thought to leave you with. Plenty of scientists argue that we're living through the opening act of the next great extinction, a sixth one, driven this time not by lava or ice or a wandering asteroid, but by us. Whether that comparison is fair is its own long argument for another day. But the deep past does whisper one thing worth hearing. Life on this planet is astonishingly hard to kill off completely. It has taken freezes and poisonings and impacts and eruptions, absorbed the worst the universe and its own chemistry could throw at it, and clawed its way back every time. The catch is that what claws its way back is never quite what went in. If you want more journeys into deep time, into the vanished worlds that came before ours and the creatures that ruled them, there is a lot more waiting for you here. 4 billion years of story sit back there in the rock, and the deeper we go, the stranger it gets. If that's a journey you want to keep taking, subscribe.